Good morning. My name is Mr. Sexton, and we were here last week. We're here to talk to you today about the distribution of light and energy. Okay. So, what is the major source of energy here on Earth? It's the sun. And where is it typically the brightest? I have a flashlight here and a piece of graph paper, and typically you're going to have the middle of it is going to be the brightest, and as the angle changes, you see that the amount of the surface area covered changes. So how will we go about changing the amount of light that is given? The angle, right. And how does it change? Well, that's what we're going to find out. We're going to divide up into groups using your popsicle sticks. We use our protractor and our ruler as our distance marker. We're going to do the same distance, but we're just going to do different angles. So you're going to take your protractor and your ruler, and you're going to use it to pick 3 different angles, and then you're going to cover, or circle where that angle is, or what your coverage, and then you're going to count up your whole squares and your half squares. You're going to add them together into 3 different angles of your choice. Okay. Now that we've done that, how does it change? That's right, the amount of area this cover changes. As long as you're at a consistent distance, the angle will change the amount of coverage. Why is that, do you think? Well, the reason why is because the quantity of light does not change, because the sun consistently puts out the same quantity of light. It's the quality of light that changes. How does it change as we move it around as far as the brightness is concerned? Right, the brightness gets dimmer because it's covering more of a surface area. So if, say at this point, what does that say about the amount of heat that is transferred? Right, when it's more straight up and down, the center of your light is going to be hotter. Here, it's not going to be as hot because it covers more area. The light's not going to be as direct. That's right. If this was the surface of the Earth, and this was the sun, what does that angle tell us? How will we describe it? Something that we experience here on Earth that describes that. Good, day and night. Day and night will do it. How else do you think we could change that? Right. That's a good way too. We could also go into seasons, where it strikes other than day and night. Right. It's going to be seasons. Okay. Well, here I have a simulated globe. Okay. So we see where the light is striking. We're going to say where my finger is us in Glasgow, Kentucky. Okay. Now, as the Earth spins, of course, the sun stays in the same place. So as the Earth spins like this, you're going to get periods of day and night. But at this angle, which the Earth is tilted at about a 22-degree angle, at this angle when it's like this, what does this indicate? The light is more directly striking us in the northern hemisphere here. So what does that say, going back to our experiment? that indicates to us that there is more energy being transferred at this point, rather than, say, let's say we'll rotate this the other way, other than when it's like this, because the light down here is getting more direct. What does that say about say the temperature down here as opposed to up here? Because it's more of a direct striking, more energy is transferred, so therefore it's going to be hotter. This is seasons, right? So at this point, we would indicate that the season here is winter. But we're getting light, but it's at more of an angle. More angle, the larger the light is spread out, the more the light is spread out, the less energy that is transferred to one single point. The amount of energy putting out is the same. It's the intensity, it's the quality, it's how strong that light is. You know, just like it's daytime here in Kentucky in the wintertime, we get light. Okay? We have an activity for you to do about ranking some different ideas that we've just went over, ranking them in order of how much light is going to be given you, and thank you for your time.